Good day, grade 12s. Now we are beginning our series of videos on the topic of electrochemical cells. So in this video, which is the part 1, we'll look at the galvanic cell. So we'll do galvanic cell. There are two types of a galvanic cell. I'll do the second type of a galvanic cell on part 2. And then on part 3 of our video, we'll look at the electrolytic cells. I think there are plus minus 4 types of cells or electrolytic cells. So now let us look at this one, the first one, which is a galvanic cell type 1. Yeah, we have a November question in front of us. So this is a galvanic cell. So we will read the statement and then we'll look at the questions that are following. So the statement here says, the diagram below represents an electrochemical cell under standard conditions. A suitable bulb in the external circuit glows brightly. So this is the diagram that they gave us. It's an electrolytic cell. It's a galvanic cell. If you look at the electrode on the left, which is this one, we have a nickel. And then in the cell, remember the galvanic cell is made up of two cells. And there is an electrolyte inside the cell. If you look at the one on the left, you have there a solution. Now this solution is made up of the nickel ions or aqueous solution. Then if you look at the electrode on the right, this one, which is Ag is a silver electrode. And if you look at the solution inside the cell on the right, it's made up of the silver ions. It's also in an aqueous state, or it's called the electrolyte. So it's a solution that can conduct electricity. And then between these two cells, we have this that we call the salt bridge. This that we call the salt bridge is where ions can move either to the left or to the right. We'll explain this one later on. Then outside the electrodes, you have your external circuit. This is where the electrons are moving either from left to right or from right to left. So this is our galvanic cell, and then this is the bulb there. That is a bulb that is glowing bright. So there are two things that you need to identify before you go to your questions on the galvanic cell diagram. So the first thing that you must identify is which electrode is the anode, which electrode is the cathode between the nickel electrode and the silver electrode. So you must first know which one is the anode and which one is the cathode. Now, after you have identified that, then you must write your oxidation half reaction and your reduction half reaction. So if you can identify these two things, then all the following questions will be very easy for you. So I'm saying the first one that we have to do, we have to identify which one is the cathode, which one is the anode. I'm talking about the electrodes now, the silver or the nickel. And then the second thing that you have to do, you have to write your oxidation half reaction and your reduction half reaction. These are the only two things that we are going to do before we go to our questions. So how are we going to approach now the first one, identification of the anode and the cathode? Okay, there's a simpler way that you can do that. So look at the electrode, which is the nickel. Now look at the solution here in the cell. You can see that you have the nickel ions. These are the nickel ions. Now I want you to notice that this is Ni2+. So we have a nickel. This is the nickel in a solid form, and this is the nickel in the aqueous form, and it's nickel 2+. So I'm going to go now to the table of potentials, and then I'm going to look for the reaction of in nickel. That's the first thing that I'm going to do. So this is your table of the standard reduction potentials. It's normally given to your question paper at the back. You can see this one. So there are two tables there. There is table 4A and there's table 4B. So I want you to notice that this one is table 4B. Here is it, table 4B. So you normally use this one. Now, what we are going to look for on this table is the reaction of a nickel. Remember, in the solution, we have the nickel 2 plus ions. So I'm looking now for a nickel. Starting at the top, I'm going down, looking for the nickel, going down. Then here I find the reaction of a nickel, this one. So you can see this is your nickel 2 plus ion plus 2 electrons, and on my right I have the nickel in a solid form. Then you look at the potential there for the nickel is negative 0.27 volts. That is the potential for the nickel. Okay, I'm going to come back now. Let us look for the second one. Remember we have on the right we have the silver Ag. So you look at the solution in the cell, we have the silver ion, which is Ag plus, and then the electrode has the silver in a solid form. This one is silver in the aqueous form. So I'm looking now for this reaction on my table 4B. Then I'm going back to my table 4B. I'm looking now for the silver. Yeah, okay. There below you can see here is silver. On the left, you have Ag plus 1 electron, which gives you the silver in a solid form. Look at the potential there for the silver is plus 0.80. That is the potential for the silver. Now, we have identified the first one, which is the nickel. We have identified the second one, which is the silver. Now, what I want you to look at again, between the two reactions now, on the left here, we have an arrow. You can see this arrow is pointing downwards, and it's a written there, oxidizing ability. Then this one, which is on the right, you can see now the arrow on the right. This one is pointing upwards. The arrow here is pointing up. You can see the arrow. And then you can see here they said reducing ability. So we have the arrow on the left that is pointing downwards. It says oxidizing ability. We have an arrow on the right pointing upwards. It says reducing ability. Now, what I'm going to do, I'm going to take this reaction, the first one, which is the one for nickel, and the second one, which is the one for the silver, and then I'm going to write them on the scrap paper. Then I'm going to explain what is happening. Okay, yeah, so look at this. So I'm saying step one, what you must do, this is the arrow that was pointing down, you remember? And it was written oxidizing ability, the one on the left. Now this is the arrow that was pointing up, and it was written reducing ability. So the first equation that we had, it was that of a nickel, which is nickel plus 2, nickel 2 plus 2 electrons, which produces that nickel in a solid form, and it had that negative 0.27 volts. The second one, which was below, it was Ag plus 1 electron to give us the Ag in a solid form, which had a potential of positive 0.80 volts. So I wrote this as it is The one that was on the top was nickel. The one that was below was the silver. So I did not change anything. Let's go back and see. So the one that was on top was the nickel one. I did not change anything. Here is the voltage for it. Then the one below was the one for silver. Here is the potential below. So the arrow is on the left is oxidizing ability. The one on the right is reducing ability. So I didn't change anything. I just wanted you to zoom in between these two reactions. So this is what now I'm going to explain to you. So we want to identify which one is a cathode and which one is the anode. Which one is the oxidizing agent, which one is the reducing agent. So after you've written these two, now what does this oxidizing ability means? The oxidizing ability means if you go down between this reaction, let's say this is a reaction A and let's say this is a reaction B. So the arrow is saying if you go down, the oxidizing ability of these two is increasing. Meaning to say that the one that is below, which is Ag, the one that is below is Ag, is an oxidizing agent. Then if you look up on the right, it says that if you go up, they are increasing in the reducing ability. That means the one that is on top, which is in this case nickel, is the reducing agent. So that's what it means. The one that is below this one is the oxidizing agent. And then the one that is below, because this arrow is pointing up, it says the one that is above, this one is the reducing agent. So you must always keep it like that. The one that is this one, the one is pointing below, is an oxidizing agent. The one that is above is a reducing agent. Just keep these two in your mind. I'm going to come back to it. So step 2, what you must do now, you must say, okay, because of we know electrons are moving from the region of lower potential energy to the regions of higher potential energy. So I'm going to say on the left I have a negative, on the right I have a positive. And I know this is my movement of electrons. Electrons are moving from the lower potential energy to the higher potential energy. In this case, I will symbolize and say it. They are moving from the negative to the positive. Between the voltages of nickel and silver, which one is negative? You can see that the nickel has a negative potential. So I'm going to say on the left side, I have negative 0.27 volts. Which one is my higher potential energy? Is the one which is silver, which is positive 0.80. So I'm going to say, okay, on this side I have positive 0.80 volts. So which one is a negative one? Is the one for the nickel. Which one is a positive one? Is the one for the silver. So if electrons are moving from the lower region to the higher regions, that means electrons are moving from nickel to silver. So the nickel in this case now, it means that it is losing electrons. The nickel is losing electrons and the silver is gaining electrons, because electrons are moving from left to right, or from negative to positive, or from lower energy region to the higher potential energy region. So I'm going to say, okay, this one must be my, remember, the loss of electrons. What is loss of electrons? Loss of electron is oxidation. We know oxidation is loss of electrons. The one that gains electrons, which is silver now, what is the gain of electrons? We know reduction is gain. So nickel is losing electron. We said that is oxidation. Oxidation is loss of electrons. And silver is gaining electrons. What is gaining of electrons? It's a reduction. A reduction is gain of electrons. So let's remember we have an, ox, and we have red cat. Then what does an ox mean? It means anode. In anode, there is a process of oxidation. Red cat means the reduction is taking place on the cathode. So an ox means oxidation is taking place on the anode. Red cat means reduction is taking place on the side of the cathode. So which one is the anode? That means the electrode of a nickel is the anode. Which one is the cathode? That means that the electrode of a silver is the cathode. On the nickel, electrons are being lost or lost. On the silver, electrons are being gained. Can you see now? So let's go back now and identify which one is a reducing agent and which one is a oxidizing agent. So go back now to your arrows. Since silver is below, this arrow is pointing downwards. It means the one that is below is the oxidizing agent, which is this one. Silver is the oxidizing agent because of it is gaining electrons. Now, which one is the reducing agent? This arrow now that is on the right is pointing upwards. It's saying the one that is above must be a stronger reducing agent, which is nickel in this case. So this one is a reducing agent. The reducing agent is the one that is being oxidized. Now, there is a problem of language here. Let's fix it now. The reducing agent is a substance that is being oxidized. Then the oxidizing agent is a substance that is being reduced. So don't worry about that, but later on we are going to come back to it. We're going to need that knowledge later on. So let's recap now. We have identified which side is cathode and which side is anode. So what did we do? We first drew our arrows, the one pointing downwards with an oxidizing ability and the one pointing up with a reducing ability. You write these two equations as they are with their potentials or with their voltages. And then the second thing that you do, you said, okay, I know that electrons are moving from the region of lower potential energy to the region of higher potential energy. You can either say I'm moving from the negative to the positive. Now, this negative and positive is just giving you an idea of which between the two substances has a lower potential energy. You can see it's the one with the which is nickel, negative 0.27, then you put it on the left. Then the one which is positive 0.80, you put it on the right. So here we say, okay, I have a nickel on the left, I have the silver on the right. So electrons will move from the nickel to the silver, from the region of lower to the region of higher. So you know that where electrons are moving from, where electrons are moving away from is our oxidation, and the oxidation is loss. Where electrons are moving towards to, on this side, on this case is silver, you can say that is my reduction, and reduction is gain. And then I know that oxidation is taking place on the anode and reduction is taking place on the cathode. And the substance that is losing electron is a reducing agent. If you forgot this, go back to your arrows. This arrow is pointing down. It says the one that is below is the oxidizing agent. This arrow that is pointing up, it means the one that is above is the reducing agent. That's why these reactions, you must write them as they are. The one that is on the top must be on the top. The one that is below must be below. So you can say the one that is above is nickel. So that's why we said nickel is the reducing agent. The one which was below is silver. You can see silver, we said, is the oxidizing agent. So that's how you identify. So everything that they will ask you on the questions will be based now on this knowledge. But there's one more thing now that I said we must do. The first one is to identify the side that is anode and cathode. We have done that. So now let us write now these two reactions with the correct form of the oxidation half reaction and the oxidation and the reduction half reaction. Now remember, we said silver, what is happening on the side of a silver? It is reduction. What is reduction? Reduction is gain of electrons. That means this reaction B, electrons must be gained. You can see that Ag plus 1 electrons gives us silver. So electrons are already on the right, which means these electrons are already being gained. I'm just going to change this double arrow now into a single forward arrow. Yeah, so you can see now that the half reaction, which is called the reduction half reaction, Ag ion or Ag plus 1 electrons gives us the Ag in a solid form. I just changed the double arrow into a single arrow. This now is called the reduction half reaction. That is called reduction half reaction. Now let us look now at the first one, the reaction A, the one for nickel. Remember we said here nickel must lose electron because is on the anode side, and what is happening on the anode is oxidation, and oxidation is loss of electrons. So electrons must be lost here on the first reaction, on reaction A. But look, the equations are on the left, so we must put them on the right. So I'm going to take all of this that is on the left, put it on the right, and take this that is on the right and put it on the left, and change the double arrow into a single arrow. Yeah, here is it. You see, the nickel was on the right, I put it on the left. The nickel 2 plus 2 electron were on the left, I put it on the right. Why do I do that? Because according to my knowledge here, I know that the nickel, what is happening on the nickel? There's a loss of electrons. So the electrons must be on the right, meaning that they were lost or they were donated. So this one now is called my oxidation half reaction, because oxidation is the loss of electrons. So I just put the electrons on the right, and then I change the double arrow to a single arrow. The one that was below, the electrons are on the left, which means they were gained, and it's correct because the silver is on the cathode side and electrons must be gained. So we have written now our two half reactions. We have identified which one is cathode, which one is the anode. So this knowledge, this information is what is going to help you to answer all the questions that they will ask you. Now let's go back now to the question paper and answer the questions. So I'm going to transfer some of the information here. We said this side of the nickel is the anode, the side of the silver is the cathode. I know my half reaction here is nickel in a solid form to a nickel 2 plus 2 electron. I know my half reaction here is Ag plus 1 electron to Ag in a solid form. Yes, this is what we got from the previous page. So now let's look at question 1.1. Which type of electrochemical cell is represented? Write only electrolytic or galvanic. So they are asking, is this cell an electrolytic or is it galvanic cell? We know it is a galvanic cell. This is not an electrolytic. An electrolytic cell has only one cell with two electrodes inside, but a galvanic cell has two cells with one electrode on either of the cells. So that's the first question. Let's look at 1.2. Write down two standard conditions applicable to this cell. There are three standard conditions for a galvanic cell to operate, but they just said we must write only two. What are these three standard conditions? Okay, so these are the three standard conditions. Number one, the temperature of the cell must be 25 Celsius degrees, or you can just say 298 Kelvin. Number two, the concentration of the solution must be 1 mole per dm cubed. Then the last one is the pressure of 1 atm or 101.3 kilopascals, only relevant for gases. So in this one, we are dealing mostly with the aqueous solution, so we can take this one and take that one. You can say the temperature must be 25 Celsius degrees and the concentration must be 1 mole per dm cubed. So you can take the first two for the answer on question 1.2. Two standard condition, you can say the temperature must be 25 Celsius degrees and concentration must be 1 mole per dm cubed. You can take these two. 1.3, in which direction do electrons flow in the external circuit? Only write down from nickel to silver or from silver to nickel. Refer to the relative strengths of reducing agents present to explain the answer. Okay, so we choose the nickel to silver because we know that this is the movement of electrons is from the nickel to silver. We have seen this from the previous information. Yeah, let's look again. The electrons, here are the electrons. They are moving from nickel to silver. Why they are moving from nickel to silver? They said refer to the reducing agent ability, because in nickel is a stronger reducing agent than silver. It's a stronger reducing agent than silver. Remember, the one that loses electron, we said it's a reducing agent. So on the side of a nickel, there will be a loss of electrons. On the side of a silver, there will be a gain of electrons. Electrons are moving from nickel to silver. That means on this side, we have a loss in mass. And then on the side of a silver, we have a gain in mass. So that question is normally 3 marks. So the first part of the answer, you said they are moving from nickel to silver. That's the first part. Then there's a following 2 marks here. They said now refer to the relative strengths of reducing agent present to explain the answer. So why they are moving from nickel to silver? Because in nickel is a stronger reducing agent than silver. So you write that down, because nickel is a stronger reducing agent than silver. That means that the nickel will release electrons. Nickel will release electrons because of it is a stronger reducing agent. It is the one that has an ability to give, to donate. So because of that, it's going to lose mass and the silver will gain mass. So this is the first mark. Then this is the explanation of why you said they are moving from nickel to silver, because nickel is a stronger reducing agent than silver, and nickel will release electrons to silver and it will lose mass. So let's go now to question 1.4. Write down the cell or symbolic notation for this cell. Write down the cell notation for this cell. So how do you write the cell notation? Okay, there are guidelines now for the cell notation. These are the guidelines. So when you write your cell notation, you must first look at the anode cell, and then in between there's a salt bridge, and then on the right there's a cathode. Always the anode must be on the left and the cathode must be on the right. So what do we have on the anode? We know that on the anode we have the nickel. And what do we have on the right, on the cathode, we have the silver. So you can see inside the solution is Ni, 2 plus ions, and then the electrode is Ni in solid form. This one is in aqueous form, that one is in solid form. So how do we write that? So we said, okay, on the anode, we have the nickel, and the nickel is the electrode in the solid form. Then we said forward slash, then we write what is inside the cell, inside the beaker. We have the solution. What is the solution inside? It is the nickel 2 plus, and it's on the aqueous form. So you can say aqueous, the concentration is 1 mole per dm cube. That is on the anode. Then there's a salt bridge. The salt bridge is represented now by double forward slash. Then you look at the cathode now, which is the one on the silver. We know that one is the Ag plus aqueous form, the concentration 1 mole per dm cube, forward slash. What is the electrode? The electrode is silver in the solid form. So this is how you write your cell notation. You start with the anode, you write the electrode. This one is the electrode in the solid form, forward slash. You come now to the electrolyte. It's in the aqueous form. Then you have your double arrow, which is the double forward slash, which is the representing the salt bridge. Then you come again to the electrolyte of this one in the aqueous form, forward slash. Then you write your electrode in the solid form. So this is normally 2 marks. Then let's look now at the last question. 1.5, second last. Which electrode will experience an increase in mass while this cell functions? I think I've already mentioned that one. Remember, the nickel is losing electron, so it's losing mass. Silver is gaining electron, so it's gaining mass. So the answer for this one is Ag. It will be silver, it will gain mass. 1.6, calculate the initial EMF of this cell. Calculate the initial EMF of this cell. This question is like 3 marks. So let's look at the formula that we're going to use to calculate the initial EMF of the cell. Okay, so this is the formula that you are going to use to find the E cell. This formula, you'll always get it in your data sheet at the back of your question paper. So it says E cell is equals to E cathode minus E anode. You must always put these small zeros on top of your E, because of all of this is in standard condition. These are standard cells, so if you don't put those zeros, they won't give you a mark for the formula. And if you look on your data sheet, this is how they wrote the formula. Then you look which one we said is the cathode. Remember, the one for silver was the one with the cathode, and it had a potential of positive 0.80 volts. The one for cathode, remember, for anode is nickel, and it had a potential of 0.27 volts. So on the side of a cathode, we're going to put now the 0.80, which is positive 0.80 minus. On the side of the anode, we're going to put the value now for the nickel, which is negative 0.27 volts. Then we know this is mathematics. A negative times negative is going to be a positive. So we need to add now these two numbers. So we have 0,80 plus 0,27. Then the answer is 1,07. So the answer is 1,07 volts. Yeah, your answer must always be positive because this is a spontaneous reaction. So it must always be positive for the galvanic cell. So I think, yeah, we have done with all our 6 questions. So this was part 1 of our video on the galvanic cell. So we'll do 2 more questions on the galvanic cell so that you can get used now to this cell before we go to the electrolytic cell. Now I'll see you now in part 2 of our video again on the electrolytic cells.